In this lesson, I will be showing you how to rationalize the denominator. What I mean by rationalizing the denominator is if you're given a problem that, let's just say an example is, let's just use random letters. So p square root 5k divided by p square root 5k. We'll do a different letter, so 5r. What we do in this scenario is whenever there is a root, square root, a cube root, any sort of root in the denominator, we would basically multiply by that root in order to cancel it out, and so we can get a proper fraction. That's essentially what rationalizing the denominator is. So if there's ever a root in the denominator, we would basically just get rid of it. Now, let's start off with a practice problem. So number 1, let's say we have 5 square root 3k squared divided by 4 square root 5k squared. Now, as I said before, our first step would be to rationalize the denominator. And we would do that by simply looking at the root in our denominator, and we would just multiply by it, 5k squared. Now, remember, whatever we do to the denominator, we have to do to the numerator as well. So we multiply by 5k squared to the denominator to get rid of that root. So we have to do it to the numerator, 5k squared. Now, what would we do after this point? We would basically just combine to get our new fraction, because we just multiplied by square root 5k squared. So we'd have to get rid of that and combine it into one big fraction. So that would become, our new fraction would become 5 square root 15k to the power of 4. Here, let me write that a little bigger. So it'll be 5 square root 15k to the power of 4 divided by 20k squared. Now, where did I get that 20k squared from? Basically, as you can tell, in the denominator, we're basically just canceling out 5k squared and 5k squared, because the same square root multiplied by itself will simply result in whatever is inside there. So that would be 5k squared. So if these roots got canceled, what's 5k squared times 4? 20k squared. So that's where I'm getting this 20k squared from. So now we've got our new equation. 5 square root 15k to the power of 4 divided by 20k to the power of 2. Now, let's simplify this as much as we can. 15k to the power of 4, that's under a square root. So what we can do is, this is nothing but 5 square root 15 k. And this is a square root, so we take it in groups of 2. And since we have 2 of them, we can bring it to the outside of the equation. And it'll be equal to now 5k squared square root 15. So our new equation will be 5k squared root 15 over 20k squared. Now we can still simplify this even further. What we do is we can take whatever is on the outside, 5k squared, and we can try and simplify it by our denominator. And that'll be 5k squared will get canceled out with 20k squared. That's nothing but 1 by 4. So this bottom will become 4. So our new equation, all that's left is this square root of 15. So our new equation will be square root of 15 over 4 as our new final solution. So that's how you rationalize the denominator. So just to recap, our first step is to look at whatever root is in our denominator and then multiply by the same thing. And whatever we do to the denominator, we must do to the numerator as well. Next step, we combine these, both of them, we combine them to create a new fraction. Once we have achieved that new fraction, we simplify it as much as we can until we reach a final final solution that you can't simplify any further. So that's our first example. Now we'll look at one more example. So here's the second example. We have minus 5x squared divided by square root of 3. Now our first step would be to rationalize the denominator. So we would basically just multiply by whatever root is in our denominator. And whatever we do to our denominator, we have to do to our numerator. So we're multiplying by square root of 3 to both. And then next, what we would do is create a completely new bigger fraction. So this would become minus 5x squared root 3 divided by, and what's root 3 times root 3 times root 3? That would just be 3. So this is our new big fraction, and we can see if this can be simplified any further. Now, we can't minus 5x squared and 3 can't be simplified. We have no other squared roots in our denominator. So what we can conclude is that we have reached our final answer. So this turned out to be a simpler problem than the first one, but you always have to be careful you have to look at every possible scenario where you can simplify it, and you want to make sure that you apply that in order to reach your final solution. So as you can tell, sometimes the final solution still has an x in it. It doesn't necessarily have to cancel out the variables. So thank you for watching this video. Be sure to like, subscribe, and watch out for future videos.